Hi, I'm Daniel Piker. Originally I studied architecture, but I'm here today to talk about embedding physical behaviour directly in the 3D modelling environment, so it can be used right from the very earliest stages of design. The designer can react to the instant visual feedback it provides, both to inform the model as it's being designed, and also to use physics to directly create the form. And this is a way of revisiting some of the old analogue techniques of form finding that were developed by people such as Gaudi and Fray Otto. And that's based on this simple idea that instead of deciding on a shape and imposing it on the material, you kind of ask the material what shape does it want to be. And so you actually directly derive the shape of it from the forces that it's resisting. And from Newton and others, we have these excellent mathematical models of physical behaviour we can use to calculate the forces on the structure and how they're going to start making it move. But of course, that's an iterative process. You move the structure and then the forces change. And before computers, these kind of soap film and hanging chain models that I showed before were the only way to actually analyse these things, but now it's possible to do it in real time, and what I'm interested in doing is actually doing it live so that you can interact with it as the simulation is running. And implementing classical mechanics in a program is very rewarding, because from a few very simple rules you can magically get this behaviour which is instantly recognisable as real physics. And when the virtual model of behaviour on screen clicks with our own internal model, then, and we all have this internal model because we've built it up since we were babies through interaction and play. And actually this instant, when what's on screen clicks with our own internal model, then it suddenly feels much more real and much more engaging. And this instant visual feedback, this kind of immediacy, along with the freedom of open-ended exploration, is similar to the qualities that make good toys. That's not to say that it's frivolous. I want what I'm doing here to be a useful creative tool which is also fun to play with. And I don't see any conflict between the two. In fact, I think they reinforce each other. So by tightening the feedback loop between structure and analysis and the design process, so it becomes a real-time interaction, then we could help designers to develop their intuition for effective forms. And it could also be useful for teaching students about basic structural principles. Now what I'm doing here, compared to a lot of the stuff that's been talked about over the last couple of days, is very basic. It's just springs and particles. And but the advantage of this is that because it's very direct, it's very simple, it goes back right to fundamental principles, that designers and people with absolutely no technical background can understand it. So what you see here is the actual way you interface with this is through Grasshopper, which works within Rhino, and it's a graphical algorithm editor, so people can build up a parametric model and define how they want the objects to relate to each other physically, and run it, and then have it drive the rest of the parametric model that they're doing. And I think one of the uses of this that I'm excited about is some people talked before about biomimicry, but it's possible now to not just mimic the natural forms, but the processes that are creating those forms. And I think this kind of process-driven design is something that designers would really like to explore, but don't necessarily have the easy enough to use tools to do this at the moment. And so what I'm really hoping is that by making it easy to use, that designers will be able to start innovating and coming up with new and different form-finding techniques. And it's still very early days at the moment. This is something I'm developing independently. But I'd really value any feedback or ideas that any of you might have. But I'll end with this. I believe that design and analysis don't need to be separate, but they could actually happen at the same time and be combined into a single process. And if architects and engineers could collaborate much more closely, then I think it could lead to all sorts of innovation. Okay, thank you very much.